Welcome back to the chemical degradation module of the HERIe platform. In this video, I would like to present how this module works. Now let us move to the HERIe website. You can access the chemical degradation module by choosing incorrect temperature, incorrect relative humidity, or by selecting chemical degradation directly from the tools at the top of the main page. Herein I have already uploaded 3 sets of environmental data for a historic building, museum, and a church. In this table you can see the values of relative humidity and temperature averaged for 1 year, but you can also see a full data range depending on the season on the graphs. When environmental data are uploaded, we can select one or a few of them and use the tool to calculate the relative lifetimes of the cellulose-based and other low-stability organic materials. Generally, relative lifetime is calculated as the ratio of a lifetime at given conditions and the lifetime at stable room conditions of 20 degrees Celsius and 50% of relative humidity. As I mentioned in the previous video, the lower temperature and relative humidity, the larger the relative lifetime of an object and thus the smaller risk of its degradation. In the case of conditions representative of museums and historic buildings, the relative lifetimes of all considered materials are slightly larger than 1, which means that these conditions are safe for objects such as paper documents or animation cells made of cellulose acetate. On the contrary, in the case of generally high relative humidity conditions, such as in a church, the expected relative lifetime of cellulose-based materials decreases by 1/3, which corresponds to a higher risk of degradation. Now let us switch to the graphs. On the bottom one you can see environmental data, and on the top corresponding values of relative lifetime. Herein IPI refers to cellulose acetate objects, sterolites to paper, and Michalski to organic materials of low stability. These graphs show that in the colder months, when the temperature decreases below 20 degrees Celsius, the relative lifetime reaches values close to 4. Contrary to that, an increase in temperature up to 27 degrees Celsius during summer results in a decrease of relative lifetime below 1. However, if we consider these temperature and relative humidity variations during a 1 year and represent them by mean values, we obtain time averaged value given in this table. The chemical degradation tool enables also the calculation of the lifetime of the paper or cellulose acetate objects stored at selected conditions. In the case of exemplary museum conditions, cellulose acetate will decompose in 48 years due to hydrolytic degradation. For further details on the calculations and formulas, please see the manual of the chemical degradation tool. Thank you for your attention and enjoy using HERIe platform.